So third one application is deriving the relation between the physical quantities. So now we are deriving the expression for time period of simple pendulum, which is depend upon the mass, length and the acceleration due to gravity, and we are using the dimension analysis to derive the expression for the time period of simple pendulum. Okay, so we are using the method of dimensional analysis. Okay, so pause and note down the first question, that is time period of simple pendulum. Expression for the time period of simple pendulum. Okay, fine. So time period of simple pendulum, it is depend upon mass. According to the given, it is depend upon the mass, okay, length and acceleration due to gravity. Okay, and we are expressing the derived quantity in terms of fundamental quantities by raising the power. By raising the powers. Power of m is we can take it as a x. Power of L is we are taking it as a y. Power of G is we are taking it as a z. Okay. So dimensions are nothing but we are raising the powers for the fundamental quantities. We express the derived quantities. Now, here we can write m power x, m power x. Dimension formula for length is we are writing the L power y. Okay. And for the acceleration due to gravity, for acceleration, what is the dimension formula? Lt minus 2. So g power z is Lt minus 2 whole power z. Okay. Why we are taking the x, y and z here? Because we have to express this quantity, okay, in the form of dimension. Dimension are nothing but powers of the fundamental quantities. Okay, so we don't know what is the power of m, how the time is varies with the l, how the time is varies with the l, how the time is varies with the g. Okay, that's why we are expressing with the unknown powers x, y, z. We have to find x, y, z values. Okay. Now we have to equate these physical quantities for the LHS and the RHS. Okay. Now equating powers of m on both sides. Equating the powers of m on both sides. Okay. So in the RHS, what is the power of m is here? In the RHS, that is x. Is there any mass quantity? Okay. Is there any mass quantity in the LHS? No. So we can write power of m is equal to 0, that is in the LHS, right? In the RHS, we can write power of m is x. X is equal to 0. We are equating powers of m on both sides. X is equal to 0. X is equal to 0. Similarly, now we can equate powers of L on both sides. Powers of L on both sides. Powers of L on both sides. Okay. So you know. So here on the RHS we are having L power y and L power z. L power y and L power z. So is there any length quantity is there in the LHS? No. That's why you can write L power 0. L power 0. ಇಲ್ಲೇನಿದೆ RHS ಬನ್ನಿ L power y ಇದೆ L power z ಇದೆ. Okay. We are equating the powers. Powers of which physical quantity? This length. Okay. So RHS. First consider the RHS power. L power y plus. Okay. So here z is related to L and z is related to p power minus 2. Okay. So here y plus z is equal to, come to the LHS. Is there any power of L is there? The power of L is 0 here. Y plus z is equal to, we can make this as 0. We are equating the powers. We are equating the powers of L on both sides. Here for L to the power of y is there. L power z is there. Here in the LHS, L power 0 is there. Okay. Y plus z. Base are same. Add the powers. Y plus z is equal to 0. Y plus z is equal to 0. Same. Okay. So another physical quantity remaining here, that is time. Okay. Now we have to equate. A powers form. Powers of t on both sides. Powers of t on both sides. So first consider the RHS. Here t power minus 2 into z is there. Okay. We have to multiply minus 2 with z. Minus 2 whole power z is there. T power minus 2z. Minus 2z. Okay. So then no other time quantity in the RHS. So come to the LHS. Here we are having, so t power plus 1. T power plus 1. Okay. So t power plus 1 means we are equating the powers. We can write this 1. T power ಏನು ಇಲ್ಲದ್ರೆ ಏನಿರುತ್ತೆ 1 ಇರುತ್ತೆ. ಇಲ್ಲಿ ಏನಿದೆ RHS ಅಲ್ಲಿ ಕಂಪೇರ್ ಮಾಡಿ. So here t power minus 2 into z minus 2z. We are equating the powers only. Power of which physical quantity? Time. Okay. Minus 2z is equal to 1. Minus 2z is equal to 1. So ಇದನ್ನ ಹೀಗೆ ಬರೆಯಬಹುದು. Z is equal to minus 1 by 2. Z is equal to minus 1 by 2 ಅಂತ ಬರೆಯಬಹುದು. Correct? Okay. So you can take this equation 1. This is equation 2. Okay. So you can take this equation 3. Substitute the value of z in equation 2. Okay. Then equation 2 implies we can write this value of z and substitute ಮಾಡಿ minus 1 by 2 ಇದೆ. Okay. Y minus 1 by 2 is equal to 0. Y is equal to plus 1 by 2. Y is equal to minus 1 by 2. RHS ಬಂದ್ರೆ plus 1 by 2 ಆಗ್ತದೆ. We got the z value, we got the y value, and from equation we got the x value. X, y, z. Then substitute value of x, y, z in this equation. Star. Okay. Equation star ಗೆ substitute ಮಾಡಿ. So ಏನಾಗುತ್ತೆ? This equation. And implies, equation star implies t is directly proportional to. So what is the power of m is there? M power x. What is the x value? 0. Okay. M power 0. Similarly, here L we are having L. Okay. L. What is the power of L here? L power y. What is the value of y we have to find out? Y, L power 1 by 2. Y is equal to 1 by 2 we obtain. L power 1 by 2. So then G power Z is Z value is minus 1 by 2. Minus 1 by 2. Okay. So finally you can write T is directly proportional to M power 0 means 1. M power 0 means 1. Okay. L power 1 by 2. L power 1 by 2. G minus 1 by 2 is that. Denominator also. It goes to the denominator. G power plus 1 by 2 agutte. Okay. So finally we can write T is directly proportional to square root of L by G anta baribodu, because L power 1 by 2, 1 by 2 na root L anta baribodu. We can write G power 1 by 2 as root G. So ಎರಡನ್ನು combine ಮಾಡಿ square root of LG anta baribodu. So time period of simple pendulum, we obtain the expression T is directly proportional to square root of L by G. Okay, this square root is applicable for both L and G. Okay, ಇಲ್ಲಿ ನೋಡಿ observe ಮಾಡಿ, L power 1 by 2 we are having, G power minus 1 by 2, G power minus 1 by 2 comes to the denominator. Okay, G power plus 1 by 2 ಆಗುತ್ತೆ. So here L power 1 by 2 is nothing but root L, G power 1 by 2 is nothing but root G. Combining these two, we can write square root of L by G. Here time period of simple pendulum, we obtain the expression square root of LG.